The next speaker, I don't know who is. Fabian, Cornelius, Thomas. Who is you, please?
I'm Fabian.
Okay, thank you very much. I didn't receive any information about the speaker. There are three authors, Fabian Musche, Cornelius Sandu, and Thomas Gritzek. And the first one is going to present flood protection of riverbank filtration wells. You have the floor.
Thank you. Good morning, everybody. In the next minutes, I want to talk about the methods we use to investigate the water tightness of flood protecting well elements and conceptual design we developed for a site in India and implemented it there. And the next slide. It's not working.
Any problem with the command?
All right. Yeah, during a flood, there are several impacts of which can decrease the removal of pathogens, but the most critical risk is the inundation of the well itself, and I want to concentrate on this. So the direct entry of the flood water can contaminate the well, and the floating debris and deposition of sand can destruction the well infrastructure. The site, our site is located in the northern part of India at the foothills of the Himalaya, and there was an extreme unprecedented flood in 2013 which destroyed the whole city, the whole site almost. Here you can see a picture after the flood, and the large sand deposition and the damage to the equipment. Due to that, the RBF well was not operational for several months, and in a groundwater well which was nearby and also inundated, we found even a higher E. coli count than in the river water, which indicated a contamination of the well. So consequently, the water supply company realized that there is a need to develop and implement flood-proofing measures to ensure water supply during flood and after floods. After the flood, we checked the vertical sealing and the presence of short circuit flow paths by a tracer test, and we used a steel cylinder around an observation well to infiltrate the salt tracer and measure the electrical conductivity on the abstracted water from the abstraction well, which was very close to the observation well. And the measurement of the electrical conductivity showed was increasing within 24 hours, nearly up to 100 microsiemens per centimeter, which indicated that the vertical sealing was not properly done, and there's a presence of short-circuit flow paths. More obvious are the vulnerable points above the ground, so the openings at the well head and cracks and fissures allow the flood water to directly enter the well. And generally in India and other developing countries, a well chamber is not constructed, which at least could protect the well from destruction. In contrast, in Europe and developed countries, there are flood-proof wells and well chambers, and the sealing of the annular space of the well bore is common and even mandatory. The well chamber are constructed above the highest flood level, or they have a watertight structure, And to get this watertight structure, there are a lot of watertight elements required, which are not available in India and other developing countries. These two pictures show flood-proof well chamber at a site on the Elbe River in Germany, and you can see two flood-proof well manhole covers and a lockable air ventilation system, and inside the well chamber there's a watertight wellhead. But anyhow, the water supply company told us from their experience that the well chambers, that most of the well chambers are flooded, are inundated during a flood event, and so we checked the water tightness of the manhole covers with the steel cylinder, and we put it on the manhole cover and then sealed it on top and put a load of 1 cubic meter of water. And then we increased the pressure with air pressure up to 1.4 meter of water column. And there was only in one out of 5 manhole cover, there was a small leakage, and which cannot inundate the well chamber. But after the testing, we were releasing the water from the tank and from the steel cylinder and simulated a small flood around the well. And then we observed that the water was entering the joints of the concrete structure. You can see it a bit here. So this indicated that the well chamber itself was not watertight. As the well elements are not available in India, we focused, or the conceptual design focused on horizontal sealing by a flood-proof wellhead connected to bitumen sheets and an apron, bentonite apron seal to achieve this horizontal sealing. And in case of an extreme flood, we allow the filtered water to enter through a seepage chamber, and by this we can reduce the buoyancy force and water pressure and the risk of contamination and the post-flood cleaning processes operation. We manufactured the wellhead, the watertight wellhead, in a local welding firm out of stainless steel, and we checked the water tightness with an air pressure up to 0.8 bar, and we applied a soap-based fluid which forms bubbles in case of leakage, but there weren't. So we took the wellhead and go to our site and installed the bitumen sheets at the basement, and then connected the wellhead to the bitumen sheets with a flange. You can see it on the right picture. And after that, the concrete work was done and the wellhead was in place. And here you can see the seepage chamber, which allows the filtered water to enter. It's filled with gravel. And around the well chamber, we applied a mixture of bentonite and sand to have the apron sealing. And for the pipe feed-through, we used a watertight PU form, which I brought from Germany, and to seal at least the annular space of the feed-through. This is the final well chamber at the site on the Alaknanda River, and we also checked the water tightness of the wellhead inside the well chamber by again inundating the well head, and then we switched off and switched on and off the well, and observed if there is some air bubbles coming out by the rising water level in the well. Finally, here are shown the capital costs of flood-proofing the well, and these are only about 10% of the total costs of such a well like in Srinagar. The work has shown that the water supply companies and engineers in developing countries or in India are not aware from the microbial contamination of wells due to floods. And we used simple methods to test the water tightness of these well elements and developed a concept with the focus on the horizontal sealing of the well and the vicinity of the well. And there's a need to establish a market for watertight well elements in India. Thank you.
Okay, thank you very much, Fabian, for this presentation. We have time for some questions. Please introduce your service. In Spain, we don't like very much the protocol, but I think it's a good thing.
Hello, my name is Harry Timmer from Oasis Water Company, and I was wondering, did you consider having your wells on an elevated platform? So raise the well 2-3 meters.
Yeah, we had this idea, but so we had limited excess of land there, so it was not possible to mount, to have a mount of earth there. And we also thought about a platform, but this would not be sufficient because of the floating debris there, because it's in the mountains, and you have large wooden debris and everything which can destroy the platform, could destroy the platform as well. And in India, it's better to make it not, to have it not accessible to the public. So a well chamber is better because you can close it and no one can go inside. And so this platform would have been interesting for everybody, and everybody would go there. And
Okay, thank you.
There is another question.
Hello, I'm Paul Baudron from Polytechnic Montreal in Canada. What about the water tightness of the bottom of the well chamber?
The bottom of the well chamber?
Yeah, can the well chamber be a recharge source for the aquifer?
We applied bitumen sheets under the well chamber.
Or maybe rather than this example, in general, when you have watertight well chambers, what about the water tightness in the bottom? Is there a possibility for water that is already inside the well chamber to infiltrate?
Sorry, I don't get it.
Okay. You talked about the water tightness of the well chamber on top, where there's an entry.
Yeah.
And what about the water tightness of the rest of the well chamber?
Yeah, we were not able to test this, so you cannot really. You have seen the last slide where we tested the wellhead itself. We inundated the wellhead, but you cannot test all elements like the pipe feed through, and this is very difficult to test. But on this site in Germany, we think that the cracks and fissures in the concrete structure inundated the well chamber.
Maybe my question leads actually to your second one. If the well chamber is completely watertight, what about buoyancy?
Yeah, actually the buoyancy, you have to compensate it. And you have the load of the well chamber itself, and yeah, that's why we have the idea to allow the flood water to enter the well chamber to compensate the buoyancy force. But actually, it's not that big problem because yeah, you have the weight of the well chamber itself, and you fix the basement of the well chamber. So yeah, this is not a big deal actually.
Okay, thank you very much.
Okay, thank you very much.